This is Devojit from Knowledge Spreader, and today I'm going to discuss on a different topic, which is matter in our surroundings. And one good news is there that I have been promoted to class 9th the last month, and that's a great news. Okay, let's mind our business. So today our topic is matter in our surroundings. First of all, what is matter? The first question after starting this chapter that comes to our mind is, what is matter? Matter means anything that occupies some space and have some mass is called matter. Means anything that have volume and have mass is called matter. Mass means what? The quantity or aggregate of something. Okay, so anything around us can be called a mass, even air also, because they occupy some space and have some mass. Okay, so let's move to another topic, which is how many states of matter are there? Generally, there are three states of matter, which are solid, liquid, and gas. So, three of them have their own characteristics. Like, I will describe four characters each of the state. First state, solid. First character is it is rigid. Rigid means the substance which cannot be bent, and which is inflexible, which is not flexible, which cannot flow, is called rigid. So solid is rigid. Second character is the force of attraction of particles in solid state is the highest because there is no space between particles. So the force of attraction obviously will be very much high, even the highest. Third character, which is the kinetic energy. Kinetic energy means what? Energy that is related to movement or related to motion is called kinetic energy. So the movement of particles in uh, solid state is the least because of the lack of space. So fourth character, which is compressibility, is the least because of the lack of space. They do not have any space to be compressed, so the compressibility is also very least. Let's move to the next state, which is liquid state. First character, it is fluid because it have the property to flow and it is very much flexible, so it is called fluid. First character. Second character, the force of attraction of particles in liquid state is lesser than solid and higher than uh, gaseous because there is a little bit amount of space between the particles. So force of attraction is quite decent. Third character, which is the kinetic energy of particles, is higher than solid but lesser than gaseous state. Fourth character, which is uh, compressibility. Compressibility is decent but not like gaseous state. So compressibility is higher than solid but as usual lesser than gaseous state. So let's move to another topic, sorry, another state, which is gas, or you can say gaseous. First character is it is fluid as usual, and as it have the character to flow, so it is recognized as fluid. Second character, the force of attraction of particles is the least because there is a huge amount of gap between one particle and another. Therefore, they do not have any force of attraction. They have, but very negligible. So, third character, which is the kinetic energy of particles in gaseous state, is the highest because the particles are super energetic and they diffuse in all directions and fill all the space of the container in which they are kept. So the kinetic energy is the highest. fourth character, which is compressibility. The compressibility is also the highest because they are highly compressible, as they have a great space, as I told earlier. So let's move to another topic, because I have discussed all the characters with proper definition, and I think you might have understood. So let's move to another topic, which is the characteristics of particles of matter. What could be the characteristics of particles of matter? It is not about a state. It is about the particles of the characteristics of particles of matter. So there, I will discuss four characteristics, which is first one, they are very small. They are microscopic, or you can say macroscopic. So first characteristic of particle of matter is they are very small. Second characteristics, which is the particles of matter have spaces between them. Third character or characteristics, you can say, is they attract each other. Particles always attract each other, means they have little bit of force of attraction, respectively with their state. So fourth character, which is they are constantly moving. That means they are not in rest, they are constantly moving. So let's move to another topic, which is diffusion. What is diffusion? Diffusion means the movement of particles on their own and mixing uniformly from higher concentration to lower concentration is called diffusion. One related term is there with diffusion, that is Brownian motion. In case of diffusion, the movement is uniform, not in a rapid way, but in Brownian motion, the movements are in rapid way. So how we will define the rapid movements or zigzag movement of particle in a matter by changing this pressure or the temperature is called Brownian motion. So Brownian motion was named after a great scientist, which is Robert Brown, in 1827. So let's move to another topic, which is uh, which is latent heat. Latent heat means the amount of heat which is necessary or required to convert one state into another, and in which the temperature remains the same. It's called latent heat. There are two main factors of latent heat, or you can say two related terms with latent heat, which is first one latent heat of vaporization, and the second one latent heat of fusion. What is latent heat of vaporization? Means the amount of heat which is required to convert 1 kg of liquid into gas at its uh, boiling point during atmospheric pressure is called latent heat of vaporization. And latent heat of fusion, the amount of heat which is required to convert 1 kg of solid into liquid at its melting point during atmospheric pressure is called latent heat of fusion. So let's move to another topic, which is cohesion. What is cohesion? Cohesion means the force of attraction of particles between each other of same kind of state is called cohesion. So let's move to another topic, which is the interconversion of states of matter. When one state is converted into another state, then it goes through some process. There is some specified name, so that I will describe. First, if I say three states: solid, liquid, and gas, suppose you try to understand it grammatically. Try to create three states in a page, and dramatically you try to understand. First, liquid, solid, liquid, gas. Okay, then you have to put solid in the top, sorry, liquid in the top, solid in the left side, and gaseous in the right side. So put them dramatically in a page and try to make a sense, which is the conversion of solid state into liquid state is called one process is there which is called fusion, which is this conversion of solid into liquid. Okay, next, the conversion of liquid into gas is called evaporation. Okay, and the conversion of gaseous into solid and vice versa is called sublimation. I have discussed many processes, and one backward process is also there. That means the conversion of gaseous state into liquid state is called condensation, and the conversion of liquid state into solid state is called solidification. So I have discussed the uh, sorry for the interruption, because some uh, relatives came into my room and I have to shift from one place to another. Sorry. So I was describing about the latent heat, and I have discussed also latent heat. Uh, so let's move to another topic, which is critical temperature. What is critical temperature? At a certain temperature, a gas cannot be converted to liquid. So that particular temperature is called critical temperature. So let's move to another topic, which is Graham's laws of diffusion. There are many uncommon words I am saying, which is in which are not mentioned in our NCRT book, but I used to read all the reference book. That's why I get to know. So I am sharing with you Graham's laws of diffusion. The rate of diffusion in gaseous state is inversely proportional to the square root of its density. So this is called Graham's laws of diffusion. Next topic, which is so I have also discussed about the Graham's laws of diffusion. So let's move to another topic, which is evaporation. What is evaporation? Evaporation means the process of conversion of uh, liquid state into gaseous state at its boiling point is called below its boiling point is called evaporation. Actually, it is a slow process. It requires a lot of time to take place, and it is a surface phenomenon. Means it occurs only at the top of a surface, or only at the uh, top layer. In it means it is not a bulk phenomenon. It only occurs at the surface of the object. So it is a surface phenomenon. So let's move to another topic, which is there are not only three states of matter. There are more than three states. So I will describe two more states, which is plasma and Bose-Einstein condensate. What is plasma? Plasma means in this state some super energetic and super excited particles are present that gets ionized when some bit of energy like electrical energy or heat energy is passed through it. So this is about all plasma state. Plasma is a type of gas which is mainly contained by uh, tube light or chlorofluoro fluorescent light. Fluorescent light. So fluorescent light and tube lights have or contain plasma because they used to give a bright uh, ray. So this bright ray generally comes from that plasma, because inside the plasma some particles are there which get ionized when electrical energy is passed. So let's move to another topic, which is Bose-Einstein condensate. In this state, some particles are present which are cooled or which are present in super cool temperature and are more uh, less heavier than normal air. So that's all about Bose-Einstein condensate. Satyendranath Bose and used that theory of this Bose-Einstein condensate, Satyendranath Bose. So let's move to another topic, which is the scale of measuring temperature. There are generally three scales or four scales. There are generally four scales to measure temperature. First one, Celsius, as we all know. Second one, Fahrenheit. Third one, Kelvin. Fourth one, Rankine. So there are four ways to measure temperature. So that's all I want to share with you all. I hope you guys have enjoyed, and sorry for the interruption because some relatives came in my room and I have to shift from there to there. So with this I want to end my video. If you enjoy, then do not forget to like and subscribe. Thank you and have a prosperous day ahead.